All right, now here we go. Learning target 4. In factoring polynomials, there are several factoring to factor them. These are the techniques that I use and the words that I use. For example, when you're factoring a polynomial, first thing you always check for is greater, except the last two that are highlighted. Those will be covered in Algebra 2 after the first quiz. Okay, but they should be reviewed. But factoring using greatest common factor, you always check for that first. Then you check how many terms there are, and if there's 3, you factor the trinomial. Now, I call it LOI, okay, to make you think about FOIL backwards. If you want to find another method to factor a trinomial, Google the words factoring trinomials. Okay? If the factor, if there are 4 terms, you factor using grouping. So 4 or more terms, factor using grouping. 3 terms, what I call LOI, but again, factor trinomials. Google that, and you can find other methods. And then last but not least, if there are 2 terms, factor using the difference of 2 squares, which is this formula. There are 2 other formulas, but we won't deal with them until later. All right, so we've got 5 examples on the first page here to try. So if you're watching the video, pause it, take as long as you need to try them. We've already done that in class. Here we go. Step 1, number 1, do they have a GCF, a greatest common factor? No. So there's 3 terms we try LOI. That simply means set up 2 parentheses with 2 blanks in both. And think about FOIL. What would you multiply to make the F term? An X and an X. What would you multiply to make the L term, the negative 24, that also adds to make the middle term? Negative 8 and positive 3. That's factoring using what I call LOI. Okay? Factoring a trinomial, it gets more difficult when the trinomial has an A value of 2 or 3. When the A is not 1, it's a little more difficult. All right, number 2, does it have a GCF? Do they have a common factor? X squared and 25? No. They don't have an X in common, and they don't share a number other than 1. So 2 terms. It must be this formula, A squared minus B squared equals A plus B times A minus B. So using that formula, our X squared is A squared, our 25 is B squared. So our A is X, our B is 5. It factors to X plus 5 times X minus 5. Number 3, it does have a GCF. Number 3 has a GCF. They share a factor of X squared. So I'm going to take X squared out of both of them, which looks like a distributive property, a distribution of a monomial. I distribute X squared backwards. So, yes? Okay, the question was, does it matter which X and minus on number 1? If you're meaning X plus 3 and X minus 8, is that okay? Is that what you're asking? That answer is fine too. It's like me asking you what are the factors of 10. And if you say 2 and 5, and someone over there says 5 and 2, you're both right. It doesn't matter what order you put them in. But it would matter if you changed it to X plus 8 and X minus 3 for this reason. When you do your outer, you get negative 3X, and your inner is 8X. And you combine those, you get a positive 5, not a negative 5. All right, good question. All right. So, and again, if you haven't done this since Algebra 1, those are the kind of questions that I'm not anticipating. So keep them coming. So back to the problem 3. X squared times what would make the X to the 4th? X squared. X squared times what would make the negative 36X squared, a minus 36. And I'll remind you, I'm going to erase this, but when you were factoring 30 using a factor tree, you might have said 5 times 6, and 5 is done. You can't factor any further. But 6 factors further to 3 and 2. That's happening right here. This X squared minus 36 is kind of like the 6. It factors further. It's 2 terms, and they're both perfect squares being subtracted. So they both factor further to X plus 6 times X minus 6. And it still has the factor X squared. Just like the prime factorization of 30 would have had the 5 times the 3 times the 2, all 3 factors. Okay? So, number 4, do they have a GCF? Highlight the final answer there. Yeah, they have a GCF of x squared. You'll take it out of all 3 things, and you'll get x squared plus x minus 6. So there's 3 things that might still factor. If they do factor, they're going to factor using what I call LOIF, or however you Google that and figure it out. So x squared times, thinking about FOIL backwards to help me factor that trinomial. The first items would be x and x, and the things that multiply to make negative 6, but add to make 2. Yeah, positive 3 and negative 2, and that doesn't factor any further. That's factored completely. Last one, 4x squared and 20x, what do they have in common? What's the GCF? They share a 4 and they share an x. So take the 4x out of both, factor it out, and you'll have an x plus a 5, and it doesn't factor any further. So that would just factor using GCF. Okay, that's old stuff. There's a whole video dedicated to factoring, the prerequisite video if you need to watch that. Now the first connection to the new stuff. All right, I'm going to rewrite number 1 as x squared minus 5x minus 24 equals 0. I just changed the problem. I just changed the original problem from a factor it expression to an equation. All right, now you can't see this on the video, but you guys in here can see. There's examples of solutions all over this board that we're going to talk about Monday mainly because of what happened on the last test. But when you solve a quadratic, your answer is 3 and 2. Things that you could plug in that would make it true. You know, in this problem, what numbers can you plug in for x that would make the left side become 0? Well, one way to do it is quadratic formula. The others, graph it and look at the x-intercept. But a way we didn't talk about is what we're going to cover today. You could have factored this to x plus 3 and x minus 8, like we said above, and then use what's called the zero product property. Zero product property is a basic concept. You're going to multiply 2 things and get 0. One of the 2 things has to be 0. Here's what I mean. Fill in the blank. Blank times 5 equals 0. What was the blank? Blank times 5, 0. All right, negative 2 times blank equals 0. All right, you get it, right? There are 2 things in that problem, x plus 3 and x minus 8, that are being multiplied. One of the 2 has to be 0. So either x plus 3 is 0 or x minus 8 is 0. And you can solve those little equations to get the 2 answers, x equals negative 3 and x equals 8. That's what Math Excel was trying to show you on a few of those problems that you clicked on View an Example, and it was showing 2 parentheses equals 0, and some of you asked me about that. I don't know, talking about if you looked at that View an Example, but it was solving by factoring. Okay, and I said at the beginning of class, I'm taking part of the blame for some of the mistakes on the first test because of vocabulary. So I'm going to really focus on it in the next few minutes because the vocabulary and the directions that are in this target, there's a lot of them, okay? All right, that's what this whole next 2 pages of the notes is dedicated to. All right, you're on page 289. If you're not there, go ahead and flip to it, page 289 in your book, so that you can see this chart. Page 289 in your lizard book, not the green one. You should have one on each group. And pause while. All right, everybody's got that box now? It's a very, very important box, especially for anyone who felt like the factoring was a little rusty and you couldn't remember some of the factoring. This is a very important box. All right, and here's what it says. The major parts for any polynomial, x minus b is a factor when b is an x-intercept. We'll start there. Meaning if you graph a polynomial, a quadratic, if you graph a function and you see where it crosses the x-axis, example 5, then you know x minus 5 would have been 5. What else is 5? Well, according to the second bullet, 5 would have been a 0 of the function. You know that second calc 0 thing, the left bound, right bound? 5 would have been a 0. Third bullet, 5 is a root for an equation. All right, now I've tried to take this box and break it down a little differently on your notes, but we're going to use this to help us learn to factor. So again, here's that page. Here's my version of that box. Okay, here's my version of that box. We know how to graph a quadratic. So here's the quadratic, x squared minus 2x minus 15. It crosses at x equals 5 and an x-intercept of x equals -3. You can read that box above if you'd like, but I've already mentioned it. Won't cover learning target 5, the different two cubes, the formulas that are highlighted until after the first quiz. Okay. So now, -3 and 5. On the left, if it's a function that you're talking about, if it's a function, y equals or f of x equals that quadratic, then -3 and 5 are called x-intercepts and they are called 0. Vocabulary, that's all I'm emphasizing because I really think that's a major player in what's causing you to miss some questions on the test is vocabulary. You look at the question, you're not really sure what it's asking, okay? So in the function world, -3 and -5 are x-intercepts and zeros. In the equation world, so if this were an equation, -3 and 5 are called two different things. They're called solutions and they're called roots. Just a context. You're looking at an equation, the question, the directions are going to say find the roots. If you're looking at a function, directions are going to say find the zero. Okay? All right, moving forward. The key concept box that we just looked at says if x equals 5, if 5 is an x-intercept, then x minus 5 is a factor. If x equals -3 is an intercept, then x plus 3 is a factor. Kind of like h. Kind of like h in vertex form. Okay? And that's what that's saying here at the very bottom. In the function world, x minus 5 and x plus 3 are factors. And in the equation world, this is factored form, which we would be able to then use the zero product property to solve and get x equals 5 and x equals -3. All right, that was really slow through all the vocabulary. Let's speed it up a little bit now. All right, I'll pause the video while you copy down the first two graphs that I've already done for you. And we're going to talk about how what we just talked about can help you factor. Okay, and we're back. All right, what I wanted to focus on here was number one, the graph of y equals x times x plus 2 times x minus 3 is this picture. Let's make some connections. If the x-intercept is -2, if the x-intercept is -2, the box we just looked at would have said, what factor does that represent? It would have represented x plus 2. All right, the x-intercept 0. The x-intercept 0, according to the box we just looked at, that would be x minus 0, the factor x minus 0, which is just x. And if the last one, x equals 3, that would be associated with the linear factor x minus 3. Can you see the connection to what was graphed? There's your x plus 2. There's your x. There's your x minus 3. You can let the x-intercept help you factor. Now, disclaimer, don't abuse that. Let it help you while you're learning to factor, but definitely make sure you're using the factoring techniques that are on the poster, because if you don't, it's going to handicap you in the next unit. Okay? Let it help you, but don't let it hurt you. All right, so now let's make another connection, number 2. Another connection. X equals 4 or -4 would have been the factor x plus 4. X equals 0 is the factor x, and x equals 5 is the factor x minus 5. But there's something different about that one. Oh, there you go. One of them is squared. Exactly. That's what I was hoping you'd see. The x equals 0 that intercept doesn't go through the x-axis. It touches it and turns around. That's the visual cue that you're looking at a double zero. Double zero. The algebraic cue that you're looking at a double zero is x squared. It's a double factor, x times x. So that's a double zero. If this were an equation, that would be called a double root. Vocabulary, okay? Vocabulary. Think you got it? What I'd like you to do, I'll pause the video too, is take number 3 and take number 4, which are in standard form, aka expanded form. Take those and write them in factored form here and here. So what you'll need is a picture. You'll need a sketch. Your Y-max, I know I said I was going to make you figure out your windows. So I'm still letting you get acquainted with that. You need a Y-max of 20 here and a Y-max of 30 here. And then write them in factored form. All right, now pause the video while you try that. Okay, to graph number 3, go to y equals and x. And now, if you didn't know, there's a button right next to the fraction button. If you'll go to math, the third option there's your cube button. No matter how old of a calculator you have, it has that, okay? So then minus 3x squared minus 4x plus 12. I'll change my window to y max 20. Graph it. And the important part, it looks like it crosses at -2, 2, and 3. I'll go to the table to confirm that. Yep, it crosses at -2, 2, and 3. So over here, -2, 2, and 3. Good enough on the sketch. Go ahead and get the picture for the next one too. Clear it out. X to the 4th, x caret 4. If you have an old, if you have an old calculator, that's probably going to look like this. X caret 4 is perfectly fine. But x to the 4th minus x math cubed minus 10x squared plus 4x plus 24. Graph it. I'll need to change my window to y max of 30 to see all of that. Okay. And then, yep, it's a degree 4, so it looks like a W. Comes down, touches, goes back up, and then does that. Close enough. The important part, where? X-intercepts, let's see. Just like last time, the x-intercepts are -2, 2, and 3. So here at x equals -2, it actually comes down, touches, and goes back up. It touches at x equals 2 and x equals 3. All right, again, I don't want this to replace your factoring techniques, but I do want it to help you while you're learning them or relearning them. So how does number 3 factor? X equals -2 is an intercept. So x plus 2 is a factor. X equals 2 would be x minus 2, and x equals 3 would be x minus 3. Are they single zeros or double zeros? They're single because they're going through the x-axis. Look at number 4. The x plus 2 here, and the x minus 2 here, and the x minus 3 here. One of those is not a single. The x plus 2 factor is a double root. So x plus 2 gets used twice, or you write it as a squared, x plus 2 squared. All right, so final answer in number 3. The factors that multiply to make that trinomial, or to make that cubic function, are x plus 2 times x minus 2 times x minus 3. That is factored form. In number 4, the x plus 2 factor is used twice, so x plus 2 squared times x minus 2 times x minus 3. Again, don't let it replace your factoring techniques, but let it help you while you're learning them. What I mean by that is number 3, to be factored by grouping. Number 4, cannot be factored with any technique we have that I'm aware of that I would use. So we'll talk about how we handle something like that later. For now, we'll just use what we have. Yes, sir. Okay. Back here at this key concept, if you know that b is an x-intercept, then you know x minus b is a factor. So when you said why do they become opposite, if 5 is your x-intercept, then x minus 5 is the factor. All right, now let's think though, what's the 0? Is it -5 or 5? The 0. It's the 5, it's the b. 5 is a 0. All right, so this key concept box is that. It's a key concept. Keep revisiting it. Take a picture of it, whatever you need. Okay, question? Yes. Okay, that would have to be discussed in the factor by grouping. Is that what, when you factor by grouping, this may be, I don't know, you may remember this, you may not, okay? But factor by grouping, you group the first two, you group the second two, and they have a GCF of x squared in the first two, and they have a GCF of either 4 or -4 in the second two, and I'll take a -4 out, and it leaves you x minus 3. So then they have an x minus 3 in common, so x minus 3 times x squared minus 4. But then that factors further to x plus 2, x minus 2. So that's the real factoring way to get to the factored form, okay? And that's a good question that leads into the bottom here. I want us to do these last 4 the real way, factoring, okay? All right, but one last thing before we get there. Expanded form, part C, expanded form. Expanded form is what number 3 and number 4 look like to begin with. Expanded form is standard form. Expanded form is standard form. So how would you take number 1, y equals x times x plus 2 times x minus 3. How would you take that? I think that was what it was, yeah. And put it in expanded form. You would do learning target 2. Distribute and distribute some more. X times x times 2, x squared plus 2x. And that binomial would be distributed to x minus 3. Again, you probably think of FOIL in that situation. X cubed minus 3x squared plus 2x squared minus 6. And you combine your like terms in the middle to get x cubed minus x squared minus 6. That's the expanded form of number 1. Same for number 2. I won't work it. It's learning target 2. To expand it, multiply it out. To factor it back to where it started. Number 1 and number 2, the original number 1 and the original number 2 are in factored form. The original 3 and the original 4 are in expanded or standard form. I don't know, I'm going really slow on the vocabulary because I really think that's part of our issue, so I'm trying to emphasize that. All right, last thing in the notes, try these 4. There are two directions. 1, put it in factored form. 2, identify the zeros. Actual factoring techniques, but while you're learning those techniques, x-intercepts and help you. All right, I'll pause the video. You try them at home. Oh, sorry, we got to start the video just for a second. It got pointed out that should have been -6x. So sorry if that confused anyone at home and here. That should have been -6x. All right, now try those last 4. Thank you. Catch up with you on number 5. Part 1, factored form. There's no GCF, so you loy. X times x would make x squared, and the things that multiply to make -24, but add to make -2, -6, and +4. That's factored form. Part 2, what are the zeros? All right, to practice what I know's coming, I want to use the zero product property, even though it's not really. But I want you to start thinking like that. If this were 0 equals x minus 6 times x plus 4, and it were in an equation, you'd be using the zero product property, which is set both of those parentheses equal to 0. X minus 6 equals 0, so x is 6, and x plus 4 equals 0, and x is negative 4 to get your zeros, okay? All right, but you know from that box earlier, that if you have a factor of x minus 1, your b was 1. Your b was 1, so your 0 is, I'm sorry, that's not a 1, that's a 6. X minus 6. If your factor was x minus 6, your b is 6, so your 0 is 6. If your factor was x plus 4, your b was negative 4, so your 0 is negative 4. All right, number 6. They have a GCF of x, so all 3, x squared minus 3x minus 2. And then if that trinomial factors, it will factor using Lloyd. Sometimes they won't, okay? Sometimes they won't, but this one does. Things that multiply to make x squared are x and x. Things that multiply to make negative 10, but add to make negative 3, negative 5, and positive 2. So that's factored form using the factoring techniques on the poster. If you graphed it and cheated it, you would have gotten the zeros first. And your x-intercepts would have been 0, 5, and negative 2. To which you could have concluded x is a factor, x minus 5 is a factor, and x plus 2 is a factor. So you could have kind of worked the problem backwards that way. Number 7, they have a GCF of 2x. So take it out. You leave an x squared minus 9 in the parentheses. And to help those that aren't in lab, you haven't seen the factor tree version of this. One of your factors is 2x, and the other is x squared minus 9. 2x doesn't factor any further, but x squared minus 9 does. X squared minus 9 factors to x plus 3, x minus 3, using the difference of 2 squares. So you end up with 3, well, technically 4 factors. You end up with 2 times x, that's technically 2 factors, times x plus 3 times x minus 3. Completely factored form. And your zeros? See, the x would say that 0 is a 0. The x plus 3 would say negative 3 is a 0, and the x minus 3 would say 3. I do want you to cheat number 8, and I'll pause it while I graph it. All right, and there's the graph on the standard 10 by 10 window. Where does it look like it crosses the x-axis? Yeah, negative 5, negative 2, 2 and 5. So that means you're going to have these factors, x plus 5, x plus 2, x minus 2, x minus 5. All right, but now how do you get there with the actual factoring technique? Technique 1, you have 3 terms, no GCF, you Lloyd. X squared times x squared is what you would multiply to make x to the 4th. Now, if the last 2 numbers are actual numbers, then your middle will be an x squared term. So what multiplies to make 100, but adds to make negative 29? Negative 25 and negative 4. Both of which are difference of 2 squares. So your first one factors to x plus 5 times x minus 5, and your second binomial factors to x plus 2, x minus 2. So that's how you get there with the actual factoring technique. And your zeros are negative 5, positive 5, negative 2, positive 2. All right, and that's learning target 4. But again, don't let the calculator mask or handicap your factoring techniques. Let the calculator help you while you're learning those again or revisiting them, okay?